dear students, welcome to Easy BTech, your guide for BTech and beyond. We are discussing about signals and systems subject. In this subject, today we are going to see problems on Fourier transform. Very important session. How to do problems on Fourier transform. And all of you, before going to problems discussion, all of you share the channel, subscribe the channel. This is very helpful to you. I am sure this channel is very helpful to you. So please follow the channel, follow the videos. Let's start our session. Problems on Fourier transform. So in the previous session we discussed the properties of Fourier transform. So using the properties we are going to see problems. Using properties we are going to see problems. So the first problem we are going to see Fourier transform of constant. Fourier transform of constant. How to do Fourier transform of constant? Just simple Fourier transform of constant. Fourier transform of constant. Constant. So take the constant is k. So what is the Fourier transform of k? Right? This constant may be any number. So this we can do using duality property. This we can do using duality property. We are going to use duality property. Duality. So we know what duality property is saying. Suppose x of t is the signal, its Fourier transform is x of omega. Then capital X of t Fourier transform is 2 pi into small x of minus omega. Small x of minus omega. So we can understand well using this cross arrows. So capital X of t Fourier transform is 2 pi into small x minus omega. So here we know that in the place of x of t I am taking del of t, impulse function, unit impulse function. Its Fourier transform is, what is the Fourier transform of del of t? 1. Right or not? Now take the 1 again. Take the 1 again. Now 1 Fourier transform is how much? According to duality property. What is the 1 Fourier transform? 1 is a constant. So what is the 1 Fourier transform as per the duality property? So 2 pi into del of minus omega. Right or not? So impulse is a even function. It is even function. Therefore del of minus omega is del of omega. Del of minus omega is del of omega. So the answer is Fourier transform of 1 is 2 pi del of omega. Right? So we want Fourier transform of k. So in the place of 1 I am taking k. Fourier transform of k, it will become 2 pi k del of omega. So k will come here. If k is equal to 1, 2 pi del of omega. If k is k, 2 pi k del of omega. So Fourier transform of 1 by 2 for example. So what is the Fourier transform of 1 by 2? K is 1 by 2. Therefore 2 pi 1 by 2 del of omega. So here 2 get cancelled. So we get pi del of omega. Pi del of omega. This is the Fourier transform of constant. Very simple and important. So as per duality property we can do it easily. Right? So using properties we can solve the problems easily. That is the property meaning or useful. Let's go to another problem. Fourier transform of Fourier transform of e power j omega naught t and e power minus j omega naught t. So what is the Fourier transform of e power j omega naught t, e power minus j omega naught t? These two we are going to see separately. So first I am going to see e power j omega naught t Fourier transform. So this is also we can do easily. Just now we have seen Fourier transform of 1. So what is the Fourier transform of 1? What we got? 2 pi del of omega. Right? Now this 1 is multiplied by e power j omega naught t. Right or not? E power j omega naught t multiplied by 1. So same e power j omega naught t. So what will be the answer? So we have frequency shifting property. That is useful now. Frequency shifting property is useful. So what is the frequency shifting property? X of t Fourier transform is x of omega. Right? Now x of t into e to the power j omega naught t Fourier transform. X of t is multiplied by e power j omega naught t. Now the Fourier transform is x of omega minus omega naught. Frequency shifting. Omega is omega minus omega naught. So same concept here. So wherever you have omega, omega minus omega naught, right? So 2 pi del of, what will be the answer now? Omega minus omega naught. So this is the e power j omega naught t. Similarly, minus j omega naught t. So that we can take as 1 into e power minus j omega naught t. So what is the answer for this? What is the Fourier transform here? 2 pi del of omega plus omega naught, because of minus sign. Here minus sign we have. So here you get plus. Understand? Clear or not? Minus j omega naught t. Here you get plus omega naught. Right? So this is the simple, very simple. Right? So using these two, we can do Fourier transform of sine and cos functions. So now the problem is Fourier transform of sine omega naught t, cos omega naught t. Sine omega naught t and cos omega naught t. So how to do sine omega naught t, cos omega naught t Fourier transform? Very simple. Let's take sine omega naught t. Sine omega naught t we can write as e to the power j omega naught t minus e to the power minus j omega naught t by 2j. Right or not? As per Euler's formula or Euler's rule, sine omega naught t is e power j omega naught t minus e power minus j omega naught t by 2j. So we want Fourier transform of sine function. That means Fourier transform of sine omega naught t is equal to, so 1 by 2j we can write outside. So Fourier transform of e power j omega naught t minus Fourier transform of e to the power minus j omega naught t. Right or not? So already we know, previously we discussed in the above problem, e power j omega naught t Fourier transform 2 pi del of omega minus omega naught, and e power minus j omega naught t Fourier transform 2 pi del of omega plus omega naught. So let's take that. So Fourier transform of sine omega naught t, sine omega naught t is equal to 1 by 2j we can write outside. So the first one, 2 pi del of omega minus omega naught minus 2 pi del of omega plus omega naught. Okay, so you can take 2 pi common, then 2 pi common by 2j. So what is the remaining? Del of omega minus omega naught minus del of omega plus omega naught. So 2 get cancelled, pi by j. This is a Fourier transform of sine omega naught t, del of omega plus omega naught. So this is the answer for sine function. And in the same way, cos function, we can do Fourier transform. So before going to cos function, just a simple example. What is the sine phi t Fourier transform? Fourier transform of sine phi t. Sine phi t. So how to do? Just already we know sine omega naught t. Take that, and in the place of omega naught, what we have? Phi. Right or not? By comparison, omega naught is equal to phi. Therefore, omega naught is equal to phi. Therefore, the answer is pi by j del of omega minus phi minus del of omega plus phi. Right? Okay. So this is a sine phi t Fourier transform. Next we can do cos function Fourier transform. So Fourier transform of cos omega naught t. Fourier transform of cos omega naught t. So first cos function we can write as exponential function, exponential in terms of exponential, e power j omega naught t plus e to the power minus j omega naught t by 2. This is the cos function, right? Then we can write this like 1 by 2 outside you can write. So Fourier transform of e power j omega naught t plus Fourier transform of e to the power minus j omega naught t. Okay, then already we know this Fourier transform of e power j omega naught t. So 1 by 2 del of 2 pi del of. So 1 by 2 2 pi del of omega minus omega naught, because here plus omega naught, that is why here minus omega naught, plus 2 pi del of omega plus omega naught, omega plus omega naught. So we can take common 2 pi. So 2 pi is outside by 2 del of omega minus omega naught plus del of omega plus omega naught. Okay, so 2 get cancelled. The remaining is the answer. Pi del of omega minus omega naught plus del of omega plus omega naught. So this is the Fourier transform of cos omega naught t. For example, if you want Fourier transform of cos 2t, what is the Fourier transform of cos 2t? So we can do it using omega naught t. What is omega naught here? 2. In the place of omega naught we have 2. So the answer is pi del of omega minus 2 plus del of omega plus 2. So this is the result. Okay. So very simple and easy. Next, go to another problem. Fourier transform of sine omega naught t into u of t. Fourier transform of sine omega naught t into u of t. So how to do it? Any idea? Sine omega naught t into u of t. So already we know Fourier transform of u of t, and sine function can be written as in terms of exponential. So see this problem, very important and easy. So Fourier transform of sine function we can write as e power j omega naught t minus e power minus omega naught j omega naught t by 2j. So this is the sine function into u of t, into u of t, right or not? So again we can do separately. 1 by 2j we can write outside. So Fourier transform of e to the power j omega naught t into u of t. Okay, minus Fourier transform of e to the power minus j omega naught t into u of t. Right? So how to do this Fourier transform of e power j omega naught t u of t? Same frequency shifting property. We have frequency shifting property. Using that we can do it. So frequency shifting property, first I write the definition here, then we follow that property. So what is the definition is saying? X of t Fourier transform is x of omega, then x of t is multiplied by e to the power j omega naught t. So answer is x of omega minus omega naught, and x of t is multiplied by e to the power minus j omega naught t. So what will be the result? X of omega plus omega naught. Right or not? This is the frequency shifting property. Now in the place of x of t, we have u of t now. Right? So u of t Fourier transform. What is the Fourier transform of u of t? 1 by j omega plus pi del of omega. Right or not? So that will be, again this u of t is multiplied by e power j omega naught t, then x of omega minus omega naught, means wherever you have omega, omega minus omega naught. Again this u of t is multiplied by e power minus j omega naught t, x of omega plus omega naught, wherever you have omega, omega plus omega naught. Understand? So I write here clearly, u of t Fourier transform is 1 by j omega plus pi del of omega. Now the first one, this e power j omega naught t into u of t. So what will be the answer? 1 by 2j. So for the first one we get 1 by j omega minus omega naught, right or not? Here omega minus omega naught. So 1 by j omega minus omega naught plus pi del of omega minus omega naught. So this is the first one, minus the second one. So I am keeping bracket for clarity. And second one, e power minus j omega naught t into u of t, this one. So x of omega plus omega naught. So this is the x of omega. We write now x of omega plus omega naught. So minus 1 by j omega plus omega naught plus pi del of omega plus omega naught. So close the bracket. This is the answer. So we can do simplification. 1 by 2j. So here pi of del pi into, not pi of, omega minus omega naught minus this minus into plus minus pi del of omega plus omega naught. Okay. So plus 1 by j omega minus omega naught, 1 by j omega minus omega minus 1 by j omega plus omega naught. Okay, so this is the answer for sin omega naught t u of t. Sin omega naught t u of t. For example, if we have sin 2t u of t, omega naught is 2. So in the place of omega naught we get 2 here, 2 here, 2 here, 2 here. That is omega naught. And in the similar way we can do cos omega naught t u of t. In the same fashion we can do cos omega naught t u of t. So find Fourier transform of cos omega naught t u of t. So this cos function can be written in terms of exponentials, e power j omega naught t plus e to the power minus j omega naught t by 2. This is the cos function into u of t. Right, now write separately 1 by 2 we can write outside. So Fourier transform of e to the power j omega naught t into u of t and plus this 1 by 2 for total. So Fourier transform of e to the power minus j omega naught t u of t. Just cos is written in terms of exponential. Then we are writing separately. So already we know this Fourier transform as per frequency shifting property. Frequency shifting property. So is equal to 1 by 2. So what is the answer for this? U of t power j omega naught t. 1 by j omega minus omega naught plus pi del of omega minus omega naught. That's all. Plus in this one also frequency shifting property. Frequency shifting property. So 1 by j, here we get omega plus omega naught plus pi del of omega plus omega naught. So close the bracket. So this is the answer for cos omega naught t u of t. For example, if you want cos 3t of t, so omega naught is equal to how much? 3. Here 3, 3, 3. Right? Very, very simple. We can do easily. Okay. Let's take another problem. Fourier transform of 1 by pi t. Very, very important. What is the Fourier transform of 1 by pi t? So if you use Fourier transform formula directly, we cannot get it, we cannot do it. Using property, we can do it. Duality property, we can do it easily. So what duality property is saying? First, we define duality property, then we can use it. So x of t Fourier transform is x of omega. Then take this x of omega and omega is t. Then its Fourier transform will become 2 pi x of minus omega. Okay. So this 1 by pi t we can do using duality property. We can do duality property. So in the place of x of t, you take signum function. So signum function Fourier transform is Sgn of t Fourier transform. What is the answer? Signum function Fourier transform, we have completed it. 2 by j omega. 2 by j omega. Now take it 2 by jt. So here t. Right or not? In the place of omega, t. Now its answer will become, its Fourier transform will become 2 pi signum minus omega. Here t minus omega. And signum function is a odd function. This is a odd function. Therefore, the Fourier transform of 2 by jt, the Fourier transform of 2 by jt. So we can write odd function as minus 2 pi signum omega. Minus 2 pi signum omega. So here 2 get cancelled. Okay, 2 get cancelled. Then 1 by jt Fourier transform is 1 by jt Fourier transform is minus pi signum of omega. So we want Fourier transform of 1 by pi t. So bring this pi left side and bring this j right side. Send that j right side. So 1 by pi t Fourier transform is, so j is coming right side. So it will become into minus j signum omega. So this is the answer. Minus j signum omega. So very, very simple. So 1 by pi t Fourier transform is minus j signum omega. Okay. So friends, dear students, watch videos regularly. You can understand every subject easily. Please subscribe, share the channel. Thank you. We meet again. We have more number of problems on Fourier transform. We discuss again. Thank you.